Hello everyone, welcome to my channel. So now we are going to do Leetcode Biweekly third question, minimum number of operation to make x and y equal. So let us first read this question, then about the constraint, examples, and then finally the coding part for the same. And before moving ahead with the coding part, do make sure that you have completely understood what I have explained and try by yourself and then only go ahead and resume the video and check for the coding part. So now let us go ahead with the explanation. First, about reading this question. So, you are given two positive integers x and y. In one operation, you can do one of the following four operations. Divide x by 11 if x is multiple of 11. Divide x by 5 if x is multiple of 5. Decrement x by 1. Increment x by 1. And we are required to return minimum number of possible operation required to make x and y equal. So now, and first if we check for the constraint, it is up to 10 raised to power 4. So here we can go ahead with n log n solution. 10 raised to power 4 can means if we go ahead with an n square solution, then it will be going ahead to n 10 raised to power 8. So it will give us TLE. So n log n or n solution would work here. Now, this first example, x equal to 26 and y equals to 1. So here if we see, so 26 is not divisible by 11, it is not divisible by 5, right? So either we can decrement it or increment it, but we require minimum operation. So here we are decrementing x by 1. So now it becomes 25 and 25 is divisible by 5. So then it will become 5 and 5 is divisible by 5, then it will become 1, which is our y, right? So this is how 1, 2 and this third. Total 3 operations we did and we got x and y equals means each other. Now they are equal. So now for 54, it is neither divisible by 5 not divisible by 11. So we decrement here, we first incremented it with 1. So it is 55. Now it becomes divisible by 11. So now it becomes 5. Now it is divisible by 5. Now it becomes 1, and if we increment 1 it becomes equals to 2. So basically here we got 4 operations. Now if we go ahead with the third example, so here 25, right, and y is greater, right? So when this would be the scenario, then we will be seriously doing just like this and we'll get our answer. Here it is 5. Okay, now the main point is this was just explanation of this question with its examples which are there. But now comes the main point, that how we will be coding this question. The point is that there are four possibilities, right? And we require the shortest path. Basically, minimum number of operation. In those four possibilities, we require the shortest path to reach our y. So in all those contexts, what we will be doing is we will be doing BFS on all the possibilities which are there and reach our destination node, that is y. Our source node here is x and destination node is y. So in that context, we will be solving our question. So if you are very much familiar with BFS, now with this much hints, you will be easily able to go ahead and code this solution without even checking the next part of this video. But if you still have any doubts in the BFS implementation, you can go ahead and check that how I will be implementing the same. So now for the BFS part, what we are required is, see, in BFS we will be requiring a queue, right? And selection of that queue is based on our requirement, right? So now before with the queue, because we are required to return answer in integer form, so let us take this. And now there are some cases that if x is already equals to y, right? So at that moment only it will just return 0. Why we are required to go ahead and do anything? Or if our y is basically greater than x, right? So in that context we will be just returning y minus x. That is all. Because what we are doing is we are taking the x as our source node and y as our destination node. So that's why it's better we go ahead and just sort it out at that moment only. Now, for doing BFS, first thing is that we will be requiring a queue. So now here queue, in that queue I'm just storing the node, is whatever possibilities are there, and that is in integer form, right? So I'm taking the queue structure as this. And I will be also required with some data structure which will keep note that it is visited or not. So in that context and for easy lookup, I will be unordered set ordered. Yeah. So I will be taking this unordered set. Unordered set is now, and we will be taking one variable distance, which will be checking that what is the distance till now it has covered. Basically, this distance would be the only one which would be our answer. So we will just remove this part. Now here we are taking this, and then for starting the BFS, we will be pushing our first node, that is our source node, which is there, that is X. And now after pushing that source node, now we are required to start the BFS, and for that we will be requiring one while loop will be check, which will be checking that if our queue is empty or not. So in that context, it will be going ahead. Now, in that also, now first we will be taking out our first node which is there by doing the operation queue dot front. And then if our node is basically equals to y, right? Now at that moment only it will return the distance. Although we can skip this step here if it would have been just the starting point. But the point is that in the ongoing process, if there is some node which we have reached at this point, that it is equals to y, then we will be at that moment only returning and we won't be going more further. Now here we will be taking size of the queue again, queue dot size, because now we are going to take one more while loop where size greater than, where it will operate until a size is greater than 0. So here node equals to q dot front, which we already got from upward also. That above operation was just for the fact node which we got already there, right? Q dot front. I'll make modification in this. Basically, it could be more optimized. Q dot pop, and here we will be just decreasing our size. Mm, yes. Now next, if a node equals to y, then we will return the distance at that moment. Now if our node, and if we do modulo by 11 equals to 0, and here comes the role for the visited part. If that portion is not present in this, then we will be simply pushing that to our queue node by 11, and also to our set which is the s dot insert node by 11. So now the same operations we are required to do, array, we are required to do for others also. Basically, this is required to be done for our case where we need to check that if it is divisible by 5. Now, if our S don't have this node plus 1, right? So in that context again, we will be pushing. Now the same thing we need to check for our minus one thing also. And then after this while loop, we will be incrementing the distance. That yeah, we completed one level. And then at the end, we will be returning our distance. Oh, you don't have the pushback, it is just push. There it is. कहाँ pushback कर दिया? Hmm. So this was the thing. Now comes the part, means basically in this all BFS operation, what we are doing is we are deciding the structure of the queue, taking a visiting array so that we don't go ahead with that node again and again just for the lookup purpose, assigning that particular source node into our queue, and then performing the BFS by taking out that particular node. And then we are checking for the fact that, 1 minute, we are checking for the fact if that particular node which is there, that particular node which is there, does that exist already or not, right? And then we are processing that node after taking that out of that queue and pushing the processed nodes into the queue again and also in the visited ones. And then after performing all this operation, we are incrementing the distance. That simply refers that we have crossed one level and now we are going ahead with the next level. And then at the end, we will be returning our distance. So now comes the part for the time complexity and the space complexity. So here we can see the time complexity here is order of one loop is this one, that it is just checking that if queue is empty or not. It will be there until our queue becomes empty or not. But the main part is in this. Means at each level it will be checking, means all the number of operations which could be there. And the size will be at max till 4 only. Because we have number of operation at max till 4 at a particular level, but it can grow exponentially when the level increases. For each it can go up to 4 into 4, like that it can go. So at max those operation also can go up to n only. And this queue which is there, क्या हो रहा है इसे? 1 minute. So basically in all those contexts it will, at, at max it can go till order of n. So that's why the time complexity will become order of n, and the space complexity here is also order of n because the queue and the set which we are using. And in all these also at max order of basically n elements can go inside. So this was all for this particular question. If you have any doubt you could comment that down, and if you really like the explanation, then do like, subscribe to my channel, and share this video among your friends. So, this was all. Thank you.